Hello everybody, this is part 2 of my more detailed video on my film scanner. In this video I'll talk about the electronics and the software. So to start off with, I'm going to talk about the sensor out here in front. It's an OmniVision 1080p 10-bit sensor. Having a 10-bit sensor really helps in this application because the film has a much higher dynamic range compared to digital photography. So having a 10-bit sensor helps capture some of that contrast ratio that's available in the film. From there, the signal is sent to the FPGA board, which is here in the back. The FPGA board handles the Bayer pattern, does color correction, lens shading correction, and detects the perforation on the film that's been scanned. Once it captures an image and does all of the corrections, it sends the image to the computer through an SDI interface. There's an SDI driver connected to it through these cables over here. The perforation detection is there to determine when the film is in the proper position to be scanned. It has a DAC up here that is connected to the motor driver over here in the back. And then the motor driver is connected to the capstan motor that pulls the film through. There's a pulse width modulated connection, so the capstan motor is able to just step through in very small increments. The challenge with controlling all of this, like I mentioned in the previous video, is that each pixel is about 8 microns on the film. So you need very precise control to be able to stop it in the proper scanning position. By having the FPGA board there, we're able to detect the perforation as it's being scanned, and then it stops the film in the proper position to be scanned. Once it's scanned, it goes into the computer and the software can take over everything else. Now we can move on to the software section. For this section, I'll just have a slide and go through all the parts of the software. I didn't film anything for this section because it would just be a terminal with numbers coming out. It wouldn't really show what's going on. First off, we have control software running in a virtual machine that sets the color correction, lens shading correction, LED brightness, everything that needs for the proper image to be scanned. It's part of an older project, so it needs to run in a virtual machine because it doesn't interact well with any of the other programs, but since you only really use it to set up the scanning process, it's not a huge issue. Next up is the software running directly on the desktop PC. There's 4 small programs that run, and each one controls a different part of the scanning process, and there's an overarching script called scan.sh that executes them in sequence while the scanning process is going. The first program that runs in the script is move to next frame. This program just sends a command to the FPGA board to advance to the next frame and stop. It doesn't do any processing, it just sends the command, everything's handled in the hardware. Because of this, the program afterwards is just wait for signal. It's an infinite loop that constantly scans the UART port for the signal from the FPGA that is in position, and once it receives the signal, it terminates and allows the script to move on to the next program. After the signal is received, the script moves on to capture identical 5 frames. This program captures 5 images from the sensor at the same frame rate that the sensor is working at. This allows it to scan the same frame on the film, however have different frames from the sensor that have different Gaussian noise distributions. By having these different frames from the sensor, we can filter the images into one image that doesn't have any of the sensor noise present in a single frame. To do the filtering, the script runs filter to one frame. It is a program that combines the 5 frames into one. However, it does not wait for it to stop since it takes a while and the scanner can keep scanning other frames while the filtering process is taking place. Because of this, the script moves straight back to move to next frame while filter to one frame is running at the same time. Once filter to one frame is done, it saves the image to file, and we can combine the image into a movie using FFmpeg or any other software. Once FFmpeg is done, then it can be edited like any other digital video file. We use DaVinci Resolve because it has nice color correction features and editing features, but really anything else would work too, Adobe Premiere, whatever. That concludes all the software for the film scanner. Thanks for watching.